Hello class and welcome to section 11.5, which is all about division of polynomials. By the end of today's lesson, you'll be able to divide a polynomial by both a monomial and a binomial. When we are dividing by a monomial, there is a simple process that we can do, and that is to take each individual piece of the polynomial and divide by the monomial. So what that's going to look like is 9x squared over 2x plus 16x squared over 2x plus 7 over 2x. So we've simply taken each piece of the polynomial and divided by that monomial value. Now what you need to look to do is see if you can reduce any of these fractions. So this first one, I have 9x squared and 2x. I can take an x out of both of them, leaving me with 9x over 2. The next one, I have 16x and 2x. So I can take an x out of both, and I can divide both by 2, giving me 8 over 1, which is just 8. And then last, I look and 7 over 2x, there's nothing to reduce there, so I leave it as 7 over 2x. So we're simply looking to see if each piece of the polynomial can be divided by the monomial, and then reducing those answers. Go ahead and try this one on your own. Dividing each piece out, you get the reduced form of b divided by 3 plus 4 minus 14 over 3b. Then we have division by a binomial. This one takes a little bit more time, and it's going to look familiar to something you did back in 4th grade, which is long division. So how we're going to set this up is we're going to take h plus 6 and put that on the outside of our division bar, and line up h squared plus 9h plus 18 on the inside. So we're going to divide each piece at a time. Then we're going to go ahead and see how many times does h go into h squared. The answer here is h times. H times h gives you h squared. So h times h is h squared. Then I'm going to take h times 6 and say plus 6h. So I figured out what times h is equal to h squared, and then I multiplied those through. Then, just like when you did long division, you're going to subtract. So h squared minus h squared makes that go away. And then I have 9h minus 6h, which gives me 3h. Just like long division, you're going to bring down the next piece, which is plus 18. Now we're going to go ahead and check how many times does h go into 3h, or what do we need to multiply by? The answer is multiply by 3. So 3 times h is 3h, 3 times 6 is 18. Then I'm going to go ahead and I'm going to subtract again. So subtracting, 3h minus 3h makes that go away, 18 minus 18 makes that go away, meaning that I have nothing left over. So our answer to this problem is h plus 3. When I do that division, I get h plus 3. Go ahead and try this one on your own. Lining that up, we got y times y is y squared. So I've got y squared plus 3y. Then I'm going to subtract, which cancels out. And negative 2y minus 3y gives me a negative 5y. Bring down the negative 15. Then I have y times negative 5 is negative 5y. Negative 5 times 3 is negative 15. Minusing a negative turns into addition, cancels that out. Again, minusing a negative turns into addition, cancels that out, for a final answer of y minus 5. Another thing we're going to look at, same kind of idea with the setup. So we've got a plus 3 on the outside, and then a squared plus 4a plus 12 on the inside. Again, a times something gives me a squared. That something is a, so a times a is a squared, plus 3 times a, which is 3a. Then we're going to go in and subtract both of those. So a squared minus a squared cancels out. 4a minus 3a gives me 1a. Bring down the plus 12. Then we've got what times a gives me 1a. The answer to that is 1. So I've got 1a plus 3. 1a minus 1a, when I subtract, that cancels out. 12 minus 3 gives me 9. Just like when you did long division in 3rd or 4th grade, this is a remainder down here. So what we would say for our answer is a plus 1 plus 9 over a plus 3. So we say our remainder over what we are dividing by. So that was the a plus 3. So our final answer is a plus 1 plus 9 over a plus 3. Go ahead and try this one on your own. There is going to be a remainder. So g goes in 3g times. So we've got 3g squared and 15g. When I subtract those, I get negative 6g and I bring down that negative 15. Multiplying by negative 6, I get a negative 6g and a negative 30. Subtracting those negatives turns into addition, which gives me 15 as a remainder. So I've got 3g minus 6 plus 15 over 5 plus g. So the last case that we are going to look at involves when we have a number missing out of our standard form. So I go n to the third and then n. In between there, we are missing n squared. So it's going to get set up the same way with 4n minus 2 on the outside. And then on the inside, we're going to start with our 8n to the third, and then we're going to add in 0n squareds. We're going to need that as a placeholder momentarily, so you need to make sure you have all of the pieces in the standard form so that the exponents are decreasing. So first we're going to check how many times 4 goes into 8. That is 2. How many times n goes into n to the third? That's n squared times. So 2 times 4 is 8, n times n squared is n to the third. Minus 2 times 2 is 4, n squared. Then I'm going to go ahead and subtract. These cancel out. Minusing a negative turns into positive 4n squared, bringing down my plus 6n. Now I need to see how many times 4 goes into 4. That's once. N goes into n squared once. So I've got 4n squared after I multiply, minus 2n. Again, we're going to need to subtract. The 4n squared and 4n squared cancel out. Minus a negative turns into a positive. So I've got 8n minus 5. Then I'm going to go ahead and go in and figure out that 4 times 2 gives me 8. So we're going to add on 2. 2 times 4n is 8n. Negative 2 times 2 is negative 4. And we're going to go ahead and subtract that out. And once I do that, the 8n's cancel. Minus a negative turns into plus 4, which gives me a negative 1. So my final answer is going to be 2n squared plus 1n plus 2 plus minus 1 over 4n minus 2. That negative comes from it being a negative 1. Go ahead and try this one on your own. Notice that you need to put it into standard form first. So we fill in that 0n squared, 0c squared, and then go through and figure out what we multiply for each one. This one turns out that there is no remainder. If you have questions about this or anything else from the lesson, please let me know when you get to class.